Hello everyone, and welcome to this presentation on binomial terms in binomial expansion. Today we are going to solve a classic problem. How many rational terms appear in the expansion of a square 2 plus root of 3 of 3 to the 100? This is a fascinating problem that tests our understanding of binomial expansion, exponent, and number theory. Let's to solve it. Here is our problem. We need to determine how many rational terms exist when we expand this expression. A rational term is one that can be expressed as a fraction of integers. In other words, no radical remains. The key is finding which term's expansion will have integer exponent for both 2 and 3 factors. Here is the expression. Square root of 2 plus third root of 3 to the 100. Find the number of terms by binomial expansion that are rational numbers. Write it to know term of the expansion. The TR plus 1 equal to 100 choose R multiply square root of 2 to the 100 minus R and third root of 3 to the R, where R equals to 0, 1, 2, and so on 100. So simplify the radicals. Square root of 2 to the 100 minus R equals to 2 to the 100 minus R over 2. And also 10 root of 3 to the R equals to 3 to the R over 3. So 3R plus 1 equals to 100 choose R multiply 2 to the 100 minus R over 2 multiplying 3 to the R over 3. So the constant for rationality for t r plus 1 to be rational, both x1 and max must be integer. 100 minus r over 2 belong to z, and also r over 3 belong to z. This means that 100 minus r must be even. And although r should be even, r must be divided by 3. So, therefore, r must be multiplied of LCM, least common multiply 2 and 3. LCM of 2 and 3 equals to 6. So, we need to count multiplied of 3 in this range. So, r larger than or equal to 0 and less than or equal to 100. We must determine the multiply of 3 in this distance. They are the multiply of 6 equal to 0, 6, 12, 18, and so on, 96. This is the arithmetic sequence. A1 is equals to 0, D equals to 6, and AN equals to 96. So 96 equal to 0 plus n minus 1 multiply 6. N minus 1 equal to 16, and n equals to 17. Check for some r. So if different value of r0 is 6, 12, 18, and 96. 100 minus r over 2 for r equal to 0 is equal to 50. And for r is 96, 100 minus r over 2 equal to 2. Also for r polar 3, when r equal to 0, r over t is 0. And for r equal to 96, r over 3 is equal to 32. So we can see that the result of 100 minus r over 2 and r over 3 are rational. So all 17 value words, and we have 17 values for this expansion. Here we can see the problem is square root of 2 and third root of 3 to the 100. The general term here, t r plus 1 equal to 100 choose r, multiply 2 to the 100 minus r over 2, multiply 3 to the r over 3. And condition for rationality, they should be divisible by 6 and number of rational terms equal to 17. And final answer, the number of rational terms is 17. Or in other words, square root of 2 and tail root of 3 to the 100 has 17 rational terms. The solution here is complete. Thanks for watching. See you in next video.